In this lesson, you learn to evaluate expressions containing variables and to translate verbal phrases into algebraic expressions. Let's take a look at this real-world example. How much do you know about your hardworking heart? An adult heart is about the size of a clenched fist. In 1 year, a human heart beats over 30 million times. The heart of a 70-year-old has beaten over 2.5 billion times. In an average lifetime, the heart pumps 1 million barrels of blood. Okay? So one way that people maintain good health is by monitoring their blood pressure. Blood pressure is the pressure that your blood exerts on your arteries. And systolic pressure is the pressure when the heart contracts, and diastolic pressure is the pressure when the heart is in between contractions. As people age, their blood pressure rises. You can approximate a person's normal systolic pressure by dividing his or her age by 2, then adding 110. So if you are a 13, 14-year-old, let's say you're 14 years old, you divide your age by 2 and then add 110. So that is 12 added to 110. So your systolic pressure should be around 120 or 117 degrees, because 14 divided by 2 is 7, sorry. Okay, and it should be around 117. Okay, your systolic pressure, that is. Okay, so what does it have to do with our lesson? Let's find out. Algebra, like any language, is the language of symbols. You know the symbols for division and addition, so you can write the blood pressure relationship as age divided by 2 plus 110. So, in arithmetic, you could write circle divided by 2 plus 110, where the circle is the person's age in years. The circle acts as a placeholder in this case. Okay? But in algebra, we use placeholders called variables. Instead of a circle, instead of a box, we use variables. Variables are usually letters. Okay? The letter X is used very often as a variable, but it's also common to use the first letter of the value you are representing. For example, you can use A to represent the age in the blood pressure relationship. So the relationship can then be written as A divided by 2 plus 110. So basically what it's saying is this: instead of a placeholder, okay, instead of this circle, we are using, okay, variables. And variables are usually letters, and the most commonly used variable, okay, letter to use as a variable is X. But in this case, we'll use A because A stands for age. So you now have A divided by 2 plus 110. Okay? And if you look at this now, okay, we now have the age divided by 2 plus 110. This is in words and symbols. Okay? Circle divided by 2 plus 110 plus 110 is arithmetic. But when you talk about A divided by 2 plus 110, this is how we say that in algebra. Okay? And A divided by 2 plus 110 is what we call an algebraic expression, because it is a combination of variables, numbers, and at least one operation. And this is now the definition of an algebraic expression. It's a combination of variables, numbers, and at least one operation. Okay? Okay. And from there, we have expressions like A divided by 2 plus 110 can be evaluated by replacing the variables with numbers and then finding the numerical value of the expression. So if you remember, when we say evaluate, it means two things. we need to do two things when you say evaluate. Okay? And that is to substitute and simplify. Okay? So we substitute and we simplify when we evaluate. Let me close some programs here because it's running very slow. Okay, maybe one more. See if it'll run faster. Alright, let's free up some memory. Alright, it should be faster. So when you say evaluate, we're talking about two things. We can substitute. And the second step is substitute. Forgot one more T here. And simplify. Okay? So a divided by 10, a divided by 2 plus 110 can be evaluated by replacing the variables with numbers and then finding the value of the expression. Moving on, let's say Malcolm is 18 years old. He could estimate his normal blood pressure by evaluating the expression 18 divided by 2 plus 110, where 18 replaces the value of A. So 18 in this case replaces the value of A right there. Oh. Okay. So 18 replaces the value of A. And that's why you have 18 divided by 2 plus 110. So following the order of operations, 18 divided by 2 plus 10. Okay. We now have copying the expression 18 divided by 2 plus 10. Substitute the value for A, which is 18. 18 divided by 2 now plus 10. End up with 9 plus 110 because 18 divided by 2 equals 9. Divide first and then add. Then we simply add 9 plus 110. We end up with 109. So Malcolm should have a systolic pressure of 119 blood pressure. Okay, so that should be Malcolm's systolic blood pressure. And from there, we come up with the substitution property of equality. Replacing A with 18 demonstrates an important property of numbers, and that's what we call the substitution property of equality for all numbers A and B. And if A is equal to B, then A may be replaced with B. And that's exactly what we just did when we had 18 being equated to A, and we simply substituted the value of 18 to A, switched it with A, and that's how we came up with 119. Let's take a look at more examples on this. Say evaluate n plus m minus 34 if n equals 18 and m equals 49. Remember, evaluate means substitute or replace and then simplify. We substitute the values for n and m, n being 18, m being 49, and this is what we come up with. Okay, 18 plus 49 minus 34. And then using the order of operations, we go from left to right. Then we add 18 plus 49 first minus 34. Okay, end up with, 67 minus 34 or 33. So The value of n plus m minus 34 if n equals 18 and m equals 49 is 33. Okay? As with a numerical expression, there is a special notation for multiplication division with variables. And we will recall 3d means 3 times d. Okay? xy means x times y. 7st means 7 times s times t. And finally, q over 4 means q divided by 4. Okay? So in algebra, you don't see a lot of the multiplication and division operations on the screen. Okay? So in this case, we want to evaluate this expression in example 2. 7x minus 4z, where x is 3, y is 8, and z equal to 5. Again, the first step in evaluating is substitute the value for x and the value for z, and that's why we end up with 7 times 3 times 4 times 5. Why is that? Because the value of x is 3 right there, and the value of z is 5 right there. Okay? So replacing that, we end up with that expression. Simplify that, you have 21 minus 20, and then use the order of operations to finally get the simplified form, which is equal to 1. Okay? So the value of 7x minus 4z given x equals 3 and z equal to 5 is equal to 1. Let's take a look at the next example. Example 2b, yz over 4. Remember, yz represents multiplication. And then we again, first rule in evaluating is substitute the values. We have 8 times 5 divided by 4. Remember, the fraction bar indicates division. So 8 times 5 divided by 4. Following the order of operations, we go from left to right. Multiply 8 times 5 first. End up with 40 divided by 4. Simplified is 10. Letter C. Again, 3x plus the quantity z plus 2y equals negative 12, or sorry, minus 12. Substitute the value for x, y, and z. We end up with 3 times 3 times 5, the quantity 5 times 2 times 8 minus 12. Following the order of operations, we need to do what's in the parentheses first. And in the parentheses, we need to multiply 2 times 8 first. So you end up with 3 times 3 plus 5 plus 16 minus 12. Simplifying 5 plus 16 further in order of operations, we have 9 plus 21 minus 12. Why 9? Because we simply multiplied 3 times 3 together. Okay? And then we added 5 plus 16. Okay? Those are actually, you can actually make that into 2 steps. But we just made it into 1. So going from left to right, 9 plus 21 is 30 minus 12 will give you 18. The value of the expression is equal to 18. That's example number 2. Okay, moving on. You can use variables to show patterns in expressions. For example, a babysitter may earn $4 an hour. The chart at the right shows several possibilities for a number of hours and earnings. Number of hours of babysitting is 2, 5, 8, and H. Okay, the money earned if she's earning $4 an hour would be $8 for 2 hours of babysitting. If she babysat for 5 hours, $20, 8 hours, $32, and following the pattern, if she babysat for 8 hours, it'll be 4H. The expression would be 4H. Remember that the variable H and the algebraic expression 4H summarize the relationship between the number of hours of babysitting and earnings. This actually, what it's saying is this actually is the, okay, that actually is the summary of all of these. Okay, so the last line summarizes the entire table right there. Okay, so again, going back here, when reading verbal sentence and writing an algebraic expression to represent it, there are many words and phrases that suggest the operation to use. The following chart shows some common phrases and operations that we can use. Okay. Look at this table, look at this chart, and I suggest you put this down in your notebook because this is you need to remember this. When you talk about addition, some words that will describe addition will be plus, sum, more than, increased by, total, in all. These all mean addition. Some words that will describe subtraction will be minus, difference, less than, subtract, decrease by. Multiplication, times, product, multiply, each, and of. And if you notice the word of, we've been using for quite a while, and every single time you see the word of, it is always multiplication. Division is dividend and quotient. So this table needs to be in your notebook. So when you encounter a word problem that will require an algebraic translation, okay, you will use these words to be able to identify what operation to utilize. Okay, let's take a look at example number 3 and see how this works. Translate each phrase into an algebraic expression. 10 more points than Maria scored. If you notice, 10 more indicates addition. Okay, so if that is the case, again, since this is a word problem, the very first step is to define our variable. Okay, 10 more points than Maria scored. We want to find the number of points that Maria scored. So let P represent the points Maria scored. The word more than suggests addition. So the algebraic expression therefore would be P plus 10 or 10 plus P. Why are they both the same? Okay, remember what we talked about in the commutative property. Okay, in the commutative property of addition. Okay, in the commutative property of addition, P plus 10 is equal to 10 plus P. Next example, B, 3 times last year's total. Remember, the first thing we need to do is define our variable. Okay, so we need to represent last year's total. In this case, we'll let T represent last year's total. The words 3 times suggests multiplication, so the algebraic expression would be 3t or 3 times t. This is what we are going to use more than anything else. Okay, 3 times t is not commonly used because the raised dot actually might be confused with a decimal. Okay, let's take a look at example number 4. Warnet Cable charges $19 a month. Okay, charges $19 a month for a basic cable TV. Each premium channel selected costs an additional $4.95 per month. Write an expression for the cost of a month of the cable service. So let's understand what the problem is asking for. It's asking for an expression for the cost of the month of cable service. Let's review our word problem. The cable company charges $19.95 a month for basic cable television. Okay, and each premium channel selected costs an additional $4.95 per month. Okay, so what do we know? Let's analyze. Representing or defining the variable, we will let n represent the total number of premium channels selected. Okay, and from there, since you are paying $4.95 for each premium channel, the total of premium channels will be $4.95 or 4.95 n. That is our expression. Okay. After we find out, after we wrote an expression for the number of premium channels, okay, the cost of the premium channels that we'll be paying for, which is the expression 4.95 n, we simply add the basic charge, which is $19.95. So we end up with $19.95 plus 4.95 n. Okay, so the word additional suggests addition, so we use addition in this case. The expression therefore is 19.95 plus 4.95n, where 19.95 represents the basic charge per month and 4.95n represents each premium channel with a cost of 4.95 per month. So the number of premium channels here will determine now the total cost per month that we need to pay. Okay? And that's the lesson for today. On Google Forms, type a summary of what you've learned by responding to the objectives of the lesson and type a question you may want to ask in class about this lesson. Thank you.